The first question for Dalton's law is for fase 05 and 06. So the first question is to define the Dalton's law of partial pressure. Then you have to calculate the mass of added nitrogen by using all information given. And next, you have to explain what will happen to the pressure if the temperature is increased. So we've got 3 questions to be answered for this past year. So the first question, the Dalton's law, the definition, okay, you just take it out from your notes. The definition is, in a mixture of unreacting gas, the total pressure is the sum of the partial pressure of individual gases. So we've done that already. Next, the question involving 2 gases. So remember class, so definitely you're going to use Dalton's law. So Dalton's law got 3 formulas, which are for total gas, partial pressure, and displacement of water. Okay, so we're gonna look which formula we're gonna use to find the answer for this Dalton's law question. Of 4 or 5 ml containing 0.52 gram oxygen, the gas pressure is increased from 745 to 980 millimeter mercury. So be note that the 745 is the initial pressure in the vessel, which only contain oxygen firstly. Okay, so this 745 is the pressure for oxygen. So after we have added the nitrogen gas, the pressure changed from 745 to 980 mmHg. So these 2 gases already combined and producing this final pressure. Well, it means that, okay, it just means that there is no product because nitrogen gas is just being put into one container with the oxygen. They are not reacting with each other to produce any products. Okay, alright, so first calculate the mass of the added nitrogen. Okay, you've already been given the final answer, so let's try and work out that one first. Alright, so we need to figure out our big formula first, which is the mass for nitrogen gas. In order to find the mass, we're going to use the formula mole of nitrogen times with the molar mass of nitrogen. Okay, so check your info. Which one already been given to you? Do we have the mole of nitrogen? No, we don't have any information regarding nitrogen. Do we have the molar mass? Yes, we can calculate this. Okay, so we need to find the mole for nitrogen gas for our second step. So check back your 3 formulas. Which one involve mole? Total gas? No. Partial pressure? Yes. We have our mole fraction. Displacement of water? Definitely no. The question does not mention anything about water. Okay, so we need to use this formula, the second one, where the partial pressure for nitrogen gas is equal to the mole fraction times with the total pressure. Okay, so you can elaborate this mole fraction into mole for nitrogen divided by mole of nitrogen plus mole of oxygen gas times total pressure. Okay, so we're gonna find our mole of nitrogen using this equation. So again, check. Do we have the pressure, the partial pressure for nitrogen? No, but we can find it because you are given both information about pressure. So the mole for nitrogen gas, we want to find it. The mole of oxygen, yes, we can calculate it. The partial pressure already been given to you, which is 980. Okay, so we can straightly find your mole for nitrogen gas. Okay, but first you need to make some notes. Alright, so for the pressure for nitrogen would be 980 minus 745. And that would be 235 millimeter mercury. Okay. We are not using the ideal gas equation, which is PV equal to nRT, so you don't have to change this unit into ATM. No. Okay, just use the unit that's been given to you in the question. Okay, what's next? Is to find the mole of oxygen. Okay, the mass is 0.52 divided by 16 times 2, which gonna be 0.01625 gram. In order to avoid confusion, I just want to let the mole of N2 equals to X. Alright, so now just substitute your partial pressure of nitrogen and the mole of oxygen into your equation. Just finish at the second step, demultiplication, right? So just bring your PT side. So it's gonna be pressure N2 divided by pressure total equals to X over X plus mole of oxygen. Okay, so pressure N2 would be 235. Pressure total would be 739. Okay, so your mass for nitrogen would be the mole 5.1258 times 10 to the power of minus 3 mole times with the molar mass 14 times 2 gram per mole. So cancel off your mole. So you've got the mass of 0.1435 gram. We're done with the first and the second question. The last question, what will happen to the pressure of the vessel if the temperature is increased? You've learned this back in physics. So when temperature increase, pressure will increase. And the question asks you to explain it. Because, okay, remember, when we're talking about temperature, our main point would be kinetic energy and frequency of collision increase.